Hello everybody and welcome to today's lesson on proving triangles similar. Today our objective is we will be able to identify and use similar triangles, and we will be able to use similarity theorems to prove that triangles are similar. But first, let's recall what similar really means. Remember, for two triangles or any type of polygons to be similar, their angles have to be congruent. All three angles have to be congruent, and all three sides have to be proportional. Let's look at this example here, and this is not in your notes, so just lean back and enjoy. I have these two triangles here, and we want to find out if they are similar. In order to do that, we need to measure the angles and the sides. I have my handy dandy math tools ready to go, my protractor and my ruler, but I already did the work for you. So the angle have the following measurements: 48 degrees, these two angles, 37 degrees, these two. Now, do I even have to measure the third angle? No, not really, because I can just use a triangle sum theorem. 48 plus 37 is 85, and take 180 minus 85, we get 95. So our third angle in both triangles is 95 degrees. Okay, so that means that this angle is congruent to this angle is congruent to this angle, and our third angles are also congruent. Okay, then all angles are congruent. Very good, we needed to know that. Check. Now I went ahead and also measured the sides of both triangles. Here are all the measurements that I made with my ruler. So let's see if those sides are proportional. 105 was the measurement of the largest side of a larger triangle, and 57 the one of the smaller triangle. Then we had the second largest side, 76 in our large triangle, and 42 in our small triangle, and the shortest side was 66 and 35. Now let's see if they're proportional, if all three ratios are the same. We can do this on our calculator since we can't simplify these fractions very easily. So just go ahead and do the math on the calculator. 105 divided by 57 is equal to 1 point, or I should say it's approximately 1.8. 76 divided by 42 is approximately 1.8, and 66 divided by 35 is approximately 1.8. These three ratios are the same, so we can say that all our sides are proportional. Check. So with all our angles being congruent and all our sides being proportional, we can indeed now say that these two triangles are similar. But are there any shortcuts that we can use to find out the same thing? Now let's see. The AA similarity postulate, and AA, as you probably will realize, stands for angle-angle. The angle-angle similarity postulate states that if two angles of a triangle, if two angles of a triangle are congruent to two angles of another triangle, then the two triangles are similar. If I draw you a little drawing, let's assume that these two triangles have two angles that are congruent, the lower left angle and the lower right angle. Remember, with our third angles theorem, if two triangles have two pairs of angles that are congruent, then the third angle is congruent as well, automatically, and therefore we have three congruent angles, and that means that these two triangles have to be similar. So the angle-angle similarity postulate is a shortcut that helps us figure this out. Here are our examples. Using the AA similarity postulate, show whether the two triangles are similar, and if they are similar, write a similarity statement. Show whether they are similar means yes or no. Are they similar? We have to figure that out. Okay, then let's see what we have in our example number 1. We have angle L, which is congruent to angle X, and the other two angles that we see are not congruent, but we can use our triangle sum theorem to figure out the third angle in each of them. JLK has two angles, 45 plus 85, that is 130, and 180 minus 130 is 50. So our third angle has 50 degrees, and we see that 50 degrees is an angle that the triangle XYZ also has. So these two triangles have indeed two pairs of angles that are congruent, and therefore, using the AA similarity postulate, we can say that these two triangles are indeed similar, and then we can go and write our similarity statement. Triangle JKL, we should always start with the one that's either to the left or on top or in a similar position, is similar to triangle. Now, which way did we go? We went from the angle with 45 degrees to the one with 50, and from there to the one with 85. So we needed to go from the one that we don't have marked here to the one with 50 degrees and to the one with 85. Y, Z, X. Triangle JKL is similar to triangle YZX. Okay, on to our next example. Here we have two triangles, but they are overlapping each other. So the first thing we should do is we should draw these two triangles again separately. So then things are going to become much clearer. Got our first triangle here, and that has angles with 50 degrees and 45 degrees. And then we have a larger triangle with angles 50 degrees and 85 degrees. Let's find the measurement of our third angle, at least one of them. 50 plus 85 is 135, and 180 minus 135 is 45. So our angle S has a measurement of 45 degrees and 45 degrees. So S is congruent to angle Q, and angle RPS is congruent to angle QPT. So we have two angles and can again say, yes, those two triangles are similar. Let's write our similarity statement. Triangle PQT. We went from P to Q to T. Angle of 50 degrees to the angle of 45 degrees to the angle of 85 degrees. So therefore that is similar to triangle PSR. Now let's write a proof showing that the two triangles are similar. When writing a proof, let's set up our table nicely. And first we want to write in anything that we have that's given. Do we have anything given? Doesn't look like that. Or do we? Let's look at our little parallel marks here. We are being given the information that GH is parallel to MN. This was actually given. Looking at our diagram with two lines crossing each other, we see that we have two vertical angles, and remember, vertical angles are congruent. We cannot just use K to name both angles because they're not the same. So let's be more specific. Angle GKH is congruent to angle MKN, and that is because they are vertical angles. Now what else can we see? Remember, whenever we have parallel lines, we should automatically look for transversals and look for special angle relationships. We have two parallel lines with actually two transversals, and you can pick either one of them. I'm just going to go with angle H, which is the alternate interior angle to angle M, and alternate interior angles are congruent. So we got angle H congruent to angle M because they are alternate interior angles. And now we have two congruent angles, and that's all we needed. So we can use our angle-angle similarity postulate to state that triangle GKH is similar to, we went from G to K to H, the angle with no mark, to the angle with one congruency mark, and to the angle with two congruency marks. That's congruent to triangle NKM, and the reason is the angle-angle similarity postulate. Alright, just a little reminder of how proofs work so we don't just forget them completely. So far so good. Now let's go ahead and watch the second part of this tutorial.